increasing and decreasing function. Now, suppose this is your function. You differentiate this function once, and wait, let me draw a table like this, a diagram. That would be a better option. That will be a better option. You have fx, here two points. Here, f dash x is greater than 0, f dash x is less than 0. If it is greater than 0, then fx is increasing. Then if less than 0, then fx is decreasing. Now, and we'll discuss along with this, I'd like to discuss with concave and convex functions also. Concave and convex functions also I'd like to discuss with this only. Now this is your fx. Further, if suppose I take f dash, wait, before I take this convex and convex, let me tell you one more thing. If f double dash, suppose f dash x I have taken. Now I take f double dash x is less than 0 and f double dash x is greater than 0. If this is greater than 0, remember one thing, that f dash x is increasing and f dash x is decreasing. We cannot tell anything about fx in this situation. From this, we cannot say anything about this. Wait. From these two conditions, this condition and this condition, from this, we cannot say fx is increasing or decreasing. From which condition? From the condition this f double dash x greater than 0 and f double dash x less than 0. From this condition, we cannot say whether it is increasing or decreasing. Whether fx is increasing or decreasing, we cannot say. We can only say that f dash is increasing and f dash is decreasing. That's all we can say. Right? But see one thing. Let me first take me an example and then make you understand. Let's take an example and understand this concept. Let us understand that fx is, let's say, 12x square minus 36, right? Okay. Now I take f dash x, that is 24x minus 36, right? And I take another function like this, fx is 36, let's write it in the other way around, 36 minus 12x, suppose x square. So f dash x here, it is 36 minus 24x. Now if I compare, अगर मैं compare करूँ 0 पे, at x0 पे, let us say at x0 पे क्या situation है function का? What is the situation at at x0 of these two functions? Both. At f dash 0, this is minus 36. So fx is decreasing at x0, is decreasing at I say, yes, at x0. And here if I take f dash 0, I get 36, which is greater than 0. This is less than 0. So Just a minute. This is less than 0. Wait a minute. So, and so here, but here it is greater than 0. So fx is, wait a minute. So fx is increasing function near 0. Increasing function uh, near, let me write near x equal to 0. Now what about if double dash x? F double dash x here would be 24, which is always greater than 0. So fx is convex function, convex. And here f double dash x is always minus 24, which is less than 0. So fx, this fx, if fx is of this form, then fx is concave. Now let us come with this example. I think you got the idea of increasing, decreasing. And let us come to this point here. Now, sorry, if, let me draw the line here, here, and here. F double dash x is greater than 0, then the function is convex. And f double dash x less than 0, let me write it somewhere a little bit here, wait. Here, f double dash x less than 0, then it is concave. Wait a minute. Concave. Then it is concave. Concave. This is the point. Now, there may be functions which can be concave and convex without being differentiable. I'll give you an example. There exists, note, there exists function, let me write, there exist function which can be concave or convex, even without being differentiable. Wait a minute. Differentiable. Take the example of, if first let me tell you what is the convex function in with definition. Concave and concave function. First we take the definition of convex function. Say if fx is a function, if fx is a function from, say, from a set S to R, the real number line S to R, if for any 2 points x1, x2 belonging to S, f of lambda x1 plus 1 minus lambda x2, this quantity is less than equal to lambda fx1 plus 1 minus lambda fx2. This is the point. This is the definition of convex. And the definition of concave is, concave, wait a minute, concave, wait a minute, concave, if fx is a function f such to S to R. Same way, if for x1, x2 belonging to S, f of lambda x1 plus 1 minus, where of course, yes, I must write lambda is in between 0 to Lambda is in between 0 to 1. Lambda can be 0, lambda can be 1, or in between 0 and 1. 1 minus lambda x2, this is less than, this quantity is less than, now this quantity will become greater than. Lambda fx1 plus 1 minus lambda fx2, where lambda is again between 0 and 1. This is the idea. Definition. Let us do one example on this. Let us see whether, let us check whether question fx mod x is convex or concave function. Before that, let me tell you three inequalities. One, major inequality, mod without proof, mod x plus y is less than mod x plus mod y. Mod x minus mod y, this is equal to mod x plus bracket mod y is less than equal to bracket mod x, this minus y, which is nothing but mod x plus y, mod y. And this, therefore mod x minus y is, this is the second result, very important result. Mod x plus mod y, wait a minute, mod y, this is mod y. One result is this, ये बहुत important result है, और ये एक बहुत बड़ा important result है. Third important result which you need here. Third important result is mod x minus 1 mod y whole mod is less than equal to mod x minus y. I am doing all this without proof. This, all three inequalities you need to remember. Now let's come to that main question I was talking about. जिस क्वेश्चन के बारे में बात कर रहे थे, क्या था मेरे पास? fx mod x था. क्वेश्चन ये था मेरा. Concave is concave or convex? Concave or convex? Or convex. Now this function is not differentiable. F mod x is equal to, you know, nothing but x for x greater than equal to 0 and x less than equal to 0 minus x. So it's not a differentiable function. Not differentiable at x equal to 0. So we cannot find f dash, cannot find f dash 0, f dash 0 is greater. We cannot find whether f dash 0 is greater than or less than 0. We cannot do this. हम ये नहीं कर सकते, हम ये फाइंड नहीं कर सकते कि f dash 0 greater than है और या less than 0 है. We do not know. So I'll take the help of, I'll take the help of definition. मैं definition का help लूंगा. Now take 2 points. X1 and X2. Take 2 points in R. F, say this F is, oh sorry, this F, I forgot to write. This F is going from R to R, from real line to real line. I forgot this part for this question. Wait, let me wait. Yes, we need to find in this part. This is my set. This is my set. Wait a minute. Yes, this part. In this part, we need to find whether this function is convex or concave. This function is concave or convex, whatever. Now, see this. Take 2 points, x1, x2 belonging to R. Now, f of this, you take lambda x1 plus 1 minus lambda x2. You take this way. So that means fx is what? Fx is what? Mod x. So this is behaving like x. पूरा x की तरह behave कर रहा है. So you take mod lambda x1 plus 1 minus lambda x2. Take a mod. Now this is behaving like x and this whole is behaving like y. So this is let's take some space here. So this quantity is less than equal to mod lambda x1 plus mod 1 minus lambda x2, where lambda is in between 0 and 1. So this quantity, this is equal to lambda mod x1 plus 1 minus lambda mod x2 and this is mod, this is mod x2. So this is nothing but lambda fx1 plus 1 minus lambda fx2. So what did I say? F of lambda x1 plus 1 minus lambda x2 is less than equal to lambda fx1 plus 1 minus lambda fx2. So, so fx is a convex function, is fx equal to mod x. Fx equal to mod x is a convex function.